This is your notes for rate of change or slope. Um, what I want to do first is just show you several ways of what I'm talking about. When I say rate of change, how much something changes over a period of time, that is equal to the slope. And a slope, remember if I had a graph, it's just like how much is my line slope? Does it go like that? It might be a real severe line like going that way. It's what's the slope of the line, okay? The slope can also be said, or the rate of change, can be the change in the y coordinate over the change in the x coordinate. These are just all ways that you're going to hear people refer to it. Let me erase this so I have more room. So my rate of change can be equal to my slope, which is equal to my change in y over my change in x. You're going to see it written like this: y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And you're also going to hear it referred to as rise over run. Those are all ways of finding the rate of change or the slope, okay? So let me say it again. Rate of change or slope is the change in y over the change in x. y2, y sub 1, but I'm just going to say y2 minus y1 over x2 minus x1, rise over run. I would say these are the two most important. You got to know that that is slope. That's the rate of change. Make sure you know those. Put big stars by them in your note. You've got to know this formula, and you've got to know that slope is rise over run. I know they're not making sense to you right now, but stay with me, and they will as we go through all of this. All right, look at this first problem. Driving time. Use the table to find the rate of change, which is also what the slope. Explain the meaning of the rate of change. Well, I've got a table here. I've got some ordered pairs in my table. I've got x and y. So my first ordered pair would be 276, and my next one would be 452. Okay, I'm just reading those straight off my chart. Now, it said find the rate of change, which we know is the same thing as the slope. Remember, the formula I gave you was y2 minus y1 over x2 minus x1. Now, let's back up for just a minute. And remember, when I gave you an ordered pair, they're always in the form x first, y second, correct? So if I have this ordered pair, 276 and 452, I could say that this is x2, and if that's x2, this has to be y2, and this is x1, y1. And then all you have to do, once I've labeled them like that, okay, notice my x and my y that are the second one, the x2, y2 are together in the same ordered pair. X1 and Y1 are together in the same ordered pair. It doesn't really matter which ordered pair you make the second one and which one you make the first one. It does not really matter as long as whichever X you use first, you use that Y first. All right, I'm going to plug these in. So I take Y2, just plug them into my formula, 76 minus Y1, Y1, 152 over x2 is 2 minus 4. So 76 minus 152 is a negative 76. 2 minus 4 is a negative 2. And then I can simplify that. A negative 76 divided by a negative 2 is a positive 38. Now, what does that mean? If my rate of change is 38, what is it? They were driving what? 38, because this is all driving, miles per hour. By looking at my chart, I know that they were going 38 miles per hour. That was my rate of change, changing 38 miles per hour. Okay? Again, if we were to graph these points on a line, we could find a slope would be at that same rate. It's like finding the slope of a line, the rate of change. Okay, look at this one. The graph to the right shows the number of U.S. passports issued in 2002, 4, and 6. Find the rate of change from 2002 to 2004 and 2004 to 2006. So looking at the chart, 2002, remember my x-axis is always the one that's my horizontal, my y is vertical. So my first order pair for 2002 to 2004, my rate of change there, is going to be what? I've got 2002, and then it was 7. And then in 2004, I've got 2004 for my x, and my y is 8.9. All right, again, using my formula, what was it? y2 minus y1 over x2 minus x1. Plugging that in, well, let's label these first. I'm going to make this x2, x1, y2. Don't know what I'm thinking there. I apologize. x1, y1. And let's plug them in. y2 is going to be 7 minus y1 is 8.9 over x2 is 2002 minus 2004. Subtracting that out, I'm going to get a negative 1.9 over 2, and you can get a calculator for this part if you need to. I'm going to get 0.95. Now, we got to look at that. What does that mean? They only changed by 0.95? No, in this case, it's 0.95 million. So what does that mean? Well, that means really I've got to do what? If I had to multiply, if you wanted to write it out and you wanted to write out 1 million times 0.95, well, really what's that going to be? It's going to be a 95 with 6 zeros, 5, 6, but then I've got 2 decimal places, right? So I'm really ending up at change by 950,000 per year. Okay? Now, in the interest of time, because I'm afraid this video may get a little long, I'm not going to do this second part, the 2004 to the 2006. But I just wanted you to see you can get that information off of a chart as well. You can get your ordered pairs from a table or from a chart. Now, the next kind we're going to look at is we're going to determine if a function is linear. Remember, we've determined if an equation is linear, and a function is really just an equation. But what if it's like given to me in a chart? Well, for a function to be linear or an equation to be linear, the rate of change or my slope, the rate of change or my slope has to be constant. It means it doesn't change from one ordered pair to the next. So I would need to see what is my rate of change from here to here. Well, that means that my ordered pairs are 1 and 6, 2 and 12. I could label those x2, y2, x1, y1. Plugging them into my formula, you remember your formula, y2 minus y1 over x2 minus x1. Told you got to know that formula, right? So I've got, what, 6 minus 12 over 1 minus 2. So that's negative 6 over negative 1, which is 6. So my rate of change from my first pair to my second pair is 6. I got to see if I have the same rate of change here. So my ordered pairs are 2, 12, and 3 and 18. So x2, y2, x1, y1. Plugging them into my formula, I've got 12 minus 18 equals 2 minus 3. I get negative 6 over negative 1, which is 6. So my rate of change from there to there is 6. Now I got to do my rate of change from the third one to the fourth one. And I've got 3 18 and 424, x2, y2, x1, y1. Just plugging all that in there. So I've got 18 minus 24 over 3 minus 4, which is negative 6 over negative 1, which again is just 6. So is my function linear? Yes, it is linear because my rate of change is constant. So yes, it's linear because every time my rate of change from one ordered pair to the next was 6. So it's constant. It is linear. Okay? Now, look at this one. Doing the same thing. Determine whether the function is linear. So I'm going to start and I'm going to go from this pair to this pair. So I've got negative 10, 5, negative 2, 1. Remember my formula. Y2 minus Y1 over X2 minus X1. Plugging those in, I've got, let's label them up here, I'm sorry. We've got X2, Y2, X1, Y1. So I've got 5 minus 1 over negative 10 minus a negative 2. Well, that's really going to become plus 2, right? So I get 4 over negative 8, which is just what, a negative 1/2. So my rate of change there is a negative 1/2. Got to check the next one. Negative 2, 1, 6, negative 4, x2, y2, x1, y1. Plugging them in, I've got 1 minus a negative 4 over negative 2 minus 6. Well, that becomes plus a 4. So that's 5 over negative 8. And is 5 over negative 8 the same thing as 1/2? No, so I can tell you right away, I don't have to do anything else. That is not linear because it does not have a constant rate of change. Okay? Now, the other kind that we're going to be looking at, just real quickly, are ones like this, where you're just finding the slope. I've given you 2 points, and you find the slope. Well, it's what you've been doing in those other problems when they were saying find the rate of change, because the rate of change is just the slope. So this is nothing new. It's nothing different. So I just have like x2, y2, x1, y1, plugging into my formula, y2 minus y1 over x2 minus x1. Plugging those in, I've got 2 minus 5 over negative 3 minus 5. So what do I have? Negative 3, and that's going to be plus a negative, over negative 8. And so a negative over negative is a positive, so my rate of change is just 3/8. Okay? So that's all you're really doing on those. It's not a whole lot different. All right, look at this was another really quick example here. Same thing. Here's what I want to show you. If I do this one, x2, y2, x1, y1, plugging those into my formula, y2 minus y1 over x2 minus x1. I promise if you'll write this down every time, you're not going to have to memorize it the night before the test because you're going to know it. All right, but y2, so I have 4 minus 4 over negative 3 minus 4. So I have 0 over negative 7. But what does 0 over negative 7 really equal? 0. So that line has a slope of 0. Okay? And again, just stay with me. I promise all this slope stuff will make more sense to you later. Okay? Now look at this one. Another just different kind of example. Again, we've got x2, y2. I'm trying to go quickly because I know this is getting long. x1, y1. Plugging them into my formula, y2 minus y1 over x2 minus x1. So I've got negative 4 minus 3 over negative 2 minus negative 2. So I've got negative 7 over 0. Can I ever divide by 0? No. So this one has an undefined slope. It is undefined. All right. Real quick, here's what I want you to realize. When you have slopes, if they go up to the right, it is positive. Up to the left is negative. Straight across is 0. Up and down is undefined. You've seen the poster hanging in my room of slope guy. This will help you remember this. Remember, if it goes up to the right, it is positive. Goes up, the slope, the line goes up to the left, it's going to be negative. If it's straight up and down, it is an undefined slope. That's what that U means. If it's straight across, the line's going to have a slope of 0. That's why those zeros are on there. But there's slope guide to help you remember where these are, what the slope looks like on a graph if it's positive, negative, 0, or undefined. Okay? All right, I want us to do one more really quick, and then we will be done for the day. All right, look at this last one. It's a different kind. It says find the value of R so that the line through 6, 3 and R2 has a slope of 1/2. Well, remember slope. Slope had the formula of y2 minus y1 over x2 minus x1. All right? So if I know that's what the slope is equal to, and you'll learn in the next chapter, not in this chapter really, we're going to designate the slope with the letter M, but it doesn't really matter at this point. And I have my points 6, 3, and R2. Let's go ahead and label those. X2, Y2, X1, Y1. And let's plug in what we know. I know M, or my slope, is 1/2. Y2 is 3, minus Y1, which is 2. X2, which is 6, minus X1, which is R. So what do I have, really? Let's work that out. I have 1/2 equals 3 minus 2 is 1 over 6 minus R. Now, there's several different ways you can solve this problem, but what do we know? When I have one fraction equals another fraction, what can I do? You can do your cross products. Remember that? When one fraction equals another one. So 1 times 6 minus R is just what? 6 minus R equals 2 times 1, which is 2. So I'm going to subtract 6 from both sides. So negative R equals negative 4, but I don't want to know what negative R equals. So I can either divide both sides by negative 1, or you can multiply both sides by negative 1. It doesn't really matter. It's the same thing. I'm just wanting to get rid of that negative. So R would be equal to 4. So if I have the slope and I'm missing one of my coordinates, I just plug it in and solve. Okay? All right, I know that's a lot of information. Just stick with me. I promise it'll all be clear the more we practice in class. All right, have a great night. I will see you tomorrow. And as always, remember what? Jesus loves you. Thanks.